In example 3, we want to find all solutions of each equation on the interval from 0 to 2 pi. So it's going to be slightly different in terms of our answer as the last couple of examples. The last examples we wanted all possible solutions. So we added on that 2n pi or that pi n if it was a tangent or cotangent. But this is just asking just list all the possible solutions in the first 4 quadrants. So you're going to have to consider all 4 quadrants and you're not adding anything onto it. So we're going to do this by factoring, so it gives you another possibility of solving. If I notice I have a cosine and a sine over here, and I have a cosine over here. So what I'm going to do is I'm going to take this 3 cosine x, and I'm going to subtract it over to the other side. And I have cosine x sine x minus 3 cosine x equal to 0. Remember, you can't factor anything unless it's set equal to 0. And since this has a cosine x and this has a cosine x, I can now factor a cosine x out. Remember, this is one term and this is another. They are not like terms. I can't combine them because this has a sine attached to it and this one does not. So if I go ahead and factor out a cosine x, in my first term, if I take the cosine x out, I'm left with the sine of x. And in my second term, if I take the cosine of x out, I'm left with a minus 3. And this is equal to 0. From here, I can take each one of these and set them equal to 0. So I'm going to take the cosine of x and set that equal to 0. And I'm going to take the sine of x minus 3 and set that equal to 0. And now basically what I've done is I've set up 2 different equations for myself to solve. Looking at the first one, cosine of x is equal to 0, I need to figure out when is the cosine of x equal to 0. So I'm going to go ahead and take a look at my unit circle. And if cosine of x is 0, hopefully by now you recognize that that would be one of your ordered pairs on your axes. So if we take a look at these, we have the point 1, 0 at angle 0. We have the point 0, 1 at pi over 2. We have the point negative 1, 0 at pi, and we have the point 0, negative 1 at 3 pi over 2. So if I take a look at when is the cosine 0, the cosine is our x, so the cosine is 0 here at pi over 2 and here at 3 pi over 2. Now remember, I'm not listing that plus at 2n pi as I am just looking at an interval from 0 to 2 pi. So my angle x would be equal to pi over 2 and 3 pi over 2. Then what I need to do is I need to look at my sine of x minus 3 equal to 0. So if I add 3 to both sides, I get the sine of x equal to 3. So I am now looking for that inverse function. I'm looking when the sine of x is equal to 3. If I think about the graph of my sine x real quick, just to give you a visual of what's happening, remember my sine function goes between negative 1 and positive 1, and it's going to keep on going that way. And I'm looking for when is the sine of x equal to 3. So what x value gives me a y value of 3? Well, 3 is all the way up here, and if you can tell, my sine function is never going to reach that. Okay, it won't ever happen, which tells me that this will not provide me with any answers. And so the only answers I have is pi over 2 and 3 pi over 2. Another way to check, take the inverse sine of 3, and you will see that you will get an error on your calculator, as it's not part of that domain of that inverse function. If you have questions, let me know. Otherwise, we're going to move on to part B. In part B, we have cosine to the 4th x plus cosine squared x minus 2 equal to 0. And what we need to do is we need to factor this. This is going to factor very similarly, if you think about it, to something like x to the 4th plus x squared minus 2. And then that might kind of throw you off a little bit, which also would factor very similar in terms of your x squared plus x minus 2. This you should be familiar with from Algebra 2, and you probably worked with this in Advanced Algebra and Trig. But we are going to use that guess and check method. So if I want to factor cosine to the 4th x plus cosine squared x minus 2, I'm going to set up my parentheses, and I'm going to go through that guess and check. So to get cosine to the fourth, or if I'm thinking about this x to the fourth, I would do x squared times x squared. So cosine to the fourth would be cosine squared x and cosine squared x. Then I need numbers that would multiply to 2 and add to 1. So I could do plus 2 minus 1, and that's equal to 0. If you're having trouble with the factoring, again, multiply it all out, make sure everything happens. So this number, these two multiplied together, plus these two have to give you that middle term. Now that I have this factored, I'm going to set each one of these factors equal to 0. So I can take cosine squared x plus 2 and set that equal to 0. And I'll take cosine squared x minus 1 and set that equal to 0. If I solve the first one, I would start by subtracting 2 from both sides. So I get cosine squared x equal to negative 2. And then I would have to take the square root of both sides. So I would get the cosine of x equal to plus or minus the square root of negative 2. Well, right here, I see that I'm taking the square root of a negative number, which can't happen. So this will not provide me with any answers. Now let's move on to the next one. Here I'm going to add 1 to both sides, and I get cosine squared x equal to 1. And then I need to go take the square root of both sides, so I have the cosine of x equal to plus or minus 1, as the square root of 1 is just 1. So now I'm looking at when is the cosine 1. Again, we should start recognizing that this is going to come from one of our axes. So if we think about those 4 points again, this is our point 1, 0. Here's 0, 1, negative 1, 0, and 0, negative 1. And I want the cosine to be plus or minus. Don't forget when you take that square root to add that plus or minus in. So positive 1 would happen over here at 0, and negative 1 is happening over here at pi. So I could say my answer for x is equal to 0 and pi. Remember, I'm not adding anything onto it, as I just want to work between 0 and 2 pi. If you have questions, let me know. Otherwise, why don't you go ahead and do the try this. So you can pause it now, unpause it when you're ready to check your answer. If you did the try this, this requires you to factor by grouping. So I'm going to go through that factoring part real quick, and then I'll tell you what the answers are. First thing you'd want to do is subtract that square root of 2 over to the other side. So we have cosine squared x plus 2 cosine of x minus 2 square root of 2 cosine of x minus the square root of 2 equal to 0. And then what I'm going to do is I'm going to group these. So I'm going to group the first two together, and I'm going to group the second two together, remembering that this 2 is really a negative if I change that to a plus. And then what I can do is I can factor out of both of these. So in this first set of parentheses, I can take out a 2 cosine x. And that leaves me with 2 cosine x plus 1. And then in the second one, oops, let's get rid of that. I'm going to factor out a negative from both of these. And then I can factor out a negative square root of 2. So I'm going to take out a minus square root of 2. And that's going to leave me with 2 cosine of x plus 1. Remember, I took a negative square root of 2 out. Negative square root of 2 divided by negative square root of 2 is still a positive 1. And that's equal to 0. And then now I'm left with 2 different terms. I have this term here and this term here. And what's positive to both of these are that 2 cosine x plus 1. So I can factor out the 2 cosine of x plus 1 from both terms. And if I take it out of the first term, I'm still left with a 2 cosine x. And if I take it out of the second term, I'm still left with a minus square root of 2 equal to 0. Then you can go ahead and set both of these equal to 0 and solve. And if you do that correctly, you should get answers that x is equal to 2 pi over 3, 4 pi over 3, pi over 4, and 7 pi over 4. If you have questions on the solving part, please let me know.